So let's get the meeting started with Chris and the Sky This Month.
Thanks. Thank you, Paul. Welcome, everybody. I'm going to cover the period of the sky from tonight, past the holidays and into New Year and into January 4th, 2023. Let's get started. So what I'm going to touch on tonight is a bit about space exploration news, and then get into observing the various doings of the sun and moon, planets, comets, asteroids, a few satellite passes, and then some things to look at in terms of variable stars, double stars, and some deep sky objects to look at during the moonless periods. I'll post the information that I'm sharing tonight on the RASCTO.ca website shortly. So for those that want the headlines and then maybe doze off or something like that, here's a summary of some of the key events of this coming month. We have the full moon tonight, going to occult Mars, which is at opposition tonight also. We have 11.5 hours of imaging time. We've got opportunities to watch the variable star Algol do its thing, a few meteor showers, and some planet motions, as well as we get the northern winter solstice as well. In terms of space exploration, we don't pay as much attention to launches as we used to, but I did pick out a few key things that are coming up in the next little while. First of all, the Artemis 1 mission is on its way back home, and it is due to re-enter Earth's atmosphere on Sunday at 1:06 p.m. Eastern Time or 18:06 UTC. So I'm sure there'll be a live broadcast of that. Sometime this month at around 3 a.m. Eastern Time, a Falcon 9 rocket will lift off from Cape Canaveral, carrying the first commercial Hakuto R lunar lander for a company called iSpace. It's iSpace Mission 1. It also includes 2 small lunar rovers from United Arab Emirates and Japan, and they will land somewhere in the Lacus Somnorium region of the moon. That's interesting. And then there is a word that sometime in December, SpaceX is planning to launch their super heavy rocket with their Starship on top of it, as seen in the picture behind the words here. And it's intended to do an Earth orbit, re-enter, and splash down. So that'll be exciting when that happens. All right, let's get into some observing. If you're interested in contributing to the tracking of the increase in light pollution in your area, there is a facility called globeatnight.org that allows you to record your observations and submit them to a database that allows people to produce maps of light pollution over time. And during the observing period, you're assigned, or they declare a particular constellation to be the target to look at. You basically head outside during the nights indicated here, December 15th to 24th, find Pegasus in your sky and just see how many of its stars you can see from where you are. They give you these handy charts that let you judge that, and then you'll log in and submit your results. Here's the contact information for the organization and the different campaigns through the year. We're at the final campaign of 2022, which is coming up during the moonless period from December 15 to 24. Speaking of the sun, we're looking at sunrises and sunsets. We've got today the sun rose at 7:37 a.m. and set this evening at 4:40 p.m. This is the year's earliest sunsets happening around the 9th, December 9th this week, giving us a total of 9 hours of daylight. By the time of our next Recreational Astronomy Night meeting on January 4th, sunrise will be at 7:51, sunset at 7:54, with again 9 hours and 3 minutes of daylight. And that will give us around the latest sunrises of the year, around January 3rd. The reason the time of daylight hasn't changed very much over that period is because we're going to hop across the northern winter solstice, which is the official shortest daylight day of the year. That happens on December 21 at 4:48 p.m. And also we get Earth at perihelion. It's closest approach to the sun, occurring on January 4th at 11 a.m. Now, astronomers are really into something called astronomical twilight and wanting to get started on their observing when that is done with. So astronomical twilight is the last bit of twilight that we get when the sun goes down. When the sun gets more than 18 degrees below the horizon, the sky gets as dark as it's going to get that night. And of course, we get a period of time where the sun is out of the picture and the sky is very dark. And then in the dawn, the sky begins to brighten up again. And so we have periods of astronomical twilight after sunset and before sunrise. So today, astronomical twilight ends at 6:23 p.m. and the sky will begin to brighten up again at 5:54 a.m., giving us 11 and a half hours of total darkness, aside from the moon, but total darkness is as dark as it can get without the sun. And we get about a minute more of that dark period per day at this time of the year. A month from now, the astronomical twilight will end at 6:37 and start in the morning at 6:07. So again, it's about 11 and a half hours. And at that point, we're getting a minute less of darkness per day. Here's just a graph of the sun daytime, nighttime balance. You see the bright areas of the daytime, the dark areas of the nighttime. And the period I'm covering is the yellow square, starting here in late December and ending in early January. In terms of the moon, we've got perigee and apogee of the moon, which astronomers typically don't worry too much about. But in terms of the phases of the moon on December 7th, so tonight, we've got our full oak or full cold or full long night's moon. The moon gets different names according to the different cultures and backgrounds that you might have. This will coincide with an occultation of Mars, which I'll come back to in a minute. On Friday, December 16th, we get the moon reaching its third quarter phase. That's when it rises beyond midnight and stays clear of the evening sky. And that third quarter moon will rise late and then linger into the morning daytime. Our new moon period, where we're completely moonless all night long, happens on December 23rd at 5:17 a.m. And that new moon will be happening almost coincident with perigee, the moon's closest approach to the Earth, which will produce extra large tides around the globe. And finally, on December 29th at 8:20 a.m., we've got the first quarter moon. So the first quarter moon rises in the afternoon, lingers until around midnight, and that's the best sort of week of the month for looking at the moon with binoculars, telescopes, and so on. All right, let's talk about Mars at opposition. That's kind of the big headline topic for today's presentation. So tonight, Mars is going to reach opposition in the sense that the Earth is moving between Mars and the sun. At opposition, a planet rises at sunset, sets at sunrise. It's closest to us at any other point in its orbit. And for Mars and Earth, these linkages or these link-ups happen every 25.6 months approximately. So this schematic here is looking down on the solar system with the sun in the middle, and it's showing you the green orbit of the Earth, rather circular, and the brown orbit of Mars, which is rather more elliptical. So Earth's orbit varies by about 3% of its distance from the sun, whereas Mars varies about 20% of its distance from the sun. And so depending on the time of the year when Earth and Mars have these alignments, these oppositions, we're at different distances away from the planet. So this opposition is happening on December 8th, 2022. And over the next number of oppositions, that distance to Mars will increase to a maximum of about 101 million kilometers in 2027. And then we'll start diminishing our distance between the two planets. The next really, really close opposition between Earth and Mars, when they're 56 million kilometers apart, will happen in 2050. So mark your calendars. But at that time, I believe Mars in a telescope will look about 50% bigger than it will at tonight's opposition. By the way, Mars was closest to Earth a week ago. And that's because at this time of the year, the orbits are diverging. They're getting wider apart with each passing day. So the geometry works out that we were actually closer to Mars a week ago. If you are getting your telescope up to look at Mars, Mars's Earth-facing side tonight around midnight will show this scene. This is an unflipped scene. So your telescope might flip this view upside down or mirror it left-right. But I've labeled some of the darker features, some of the more significant features, especially the Terrena Terra and the Syrtis Major Planum, which looks like a dark wedge pointing basically towards Mars's polar cap. So you should expect to see the polar cap shining brightly near the edge of Mars's disk if you have a decent sized telescope. Tonight, you'll get a peak brightness in the sky of minus 1.97 magnitude. That's actually enhanced a little bit at opposition by something called the opposition surge or the Seeliger effect, where the sunlight hitting the object dead on and reflecting back right towards us and back towards the sun behind us actually enhances the brightness a little bit beyond what it would normally be. Mars will be 82.15 million kilometers away. It's about 4.72 light minutes distance. And in a telescope, it'll appear 17 arc seconds wide. That's about a third the size of Jupiter, maybe a bit more than a third the size of Jupiter. Now, after this week, Mars will start to get fainter in the sky. It'll get smaller in telescopes. The green graph here shows us Mars was largest last week on November 30th, and now it will start to decrease in size when viewed in a telescope. Each of these vertical lines is about a week. And you can see that the peak brightness, the yellow line, is at a max tonight, and it'll actually continuously fade over the next little while. Mars will remain in our skies for a number of weeks and months, but it will definitely lose its luster over the coming days. Now, if you're planning to take a look at Mars, here are some tips. So try to look at the planet when it's highest in the sky, if possible. You don't need to wait until 1 a.m. when it's highest, but certainly try not to look at it through your telescope when it's too near to the horizon. Higher is better. If the air is a bit turbulent, take long looks at the eyepiece to capture the moments when you see some clarity. It'll snap into clarity occasionally if you take your time. You could take a look to see if you can find the moons of Mars. They're faint, magnitude 11.5 and 12.5, so it's better if you have a big telescope if you want to have a hope of seeing those moons. Also, tonight wouldn't be the night, as I'll get to in a second. You can find a nice online Mars mapping tool that is here at nightskies.net/skyguide/Mars. It actually lets you look at two different views of the planet, labeled and unlabeled, and you can actually set the time and date to match when you're seeing the planet. Now, you can use filters on Mars to make it look a little better. You might even find Mars is too bright through a telescope tonight. If you find that's the case, maybe try putting your moon filter on Mars to diminish its brightness a little bit, and that might pick up some of the features a little bit better. Or you can use some colored filters as listed here to enhance particular aspects of the planet. You don't need filters, but these are some ways that you can get alternate views of it that might be a little bit better. All right, so here's the big news. So tonight the full moon is opposite the sun, and so also is Mars opposite the sun. And it'll turn out that the moon is going to pass in front of or occult Mars for observers located in this band. So basically all of North America, or most of Canada, all of the USA, across the Atlantic, and into parts of Northern Africa. In Toronto, the Mars will ingress or move behind the moon at 10:28:39 p.m. Eastern Time. And that will take about 75 seconds for that event to happen. Mars will reappear at 11:16:29, again, taking about 80 seconds for that to happen. And it'll emerge from the southeastern limb of the moon between Tycho and Stevinus. Let me just show you that in Stellarium here. So bring this up and zoom in, and we'll get into the evening here. All right. So the moon moves by its own diameter about once an hour. So by the time we get to 10 p.m., this is the sky for Toronto. And by the way, this star Kappa Tauri, which is kind of following Mars, will also be occulted by the moon a bit later in the evening. So I'm just going to advance the time. Here we are getting close to that appointed time of 10:29 or so. Zoom in here a little bit more. And you can see that if you advance the time in seconds, it takes about 70 seconds for the moon to completely cover the planet. Now, in this case, the moon is full. So that means we've got lit limbs of the moon on both sides. Sometimes when we're doing occultations of other objects, we're dealing with a moon that's lit on one side and dark on the other. In this case, it's lit on both sides. And the Mars will emerge from behind the moon's opposite limb, starting at about, for Toronto, at about 11, here we go, 11:16 or so, and a few seconds. Now, where you are in Canada, if you're watching us tonight from another location, the location where Mars emerges from behind the moon will vary according to your location. Now, if you want to be safe, you could use a low magnification eyepiece that fills the entire moon, and then watch Mars when it peeks out. If you want to get that nice close-up view, then you need to figure out where exactly to focus your attention on the moon at the appointed time. So as I said, in this case, here's Tycho, here's Stevinus, so the Mars will reappear kind of in the moon's lower right quadrant. If you're viewing the event from further west in Canada, the Mars will emerge at a more northerly location. So I think in Winnipeg, Prairie provinces, it'll be up here kind of near Mare Frigoris, the start patch here. And then if you're in Vancouver, it'll be up here near Mare Crisium. If you're out in the Maritimes, Mars will just skim through the southern pole of the moon. So it'll kind of disappear here and emerge right about here. So that's something to definitely get onto. Now, just get back to my Here we go. Now, if you haven't got your telescope ready for the event, we could pause my video now, go off and get your telescope, get set up, get it ready to go. Put it outside if you've got cold weather where you are. Get your telescope outside, get it chilling down. You've got a few hours to do that, and then come back and put me on 1.25 and catch up. All right, here's some of the events that are happening in terms of the planets this month. So we have Mercury and Venus are hanging out just above the western horizon after sunset. Mercury will reach its most visible night on December 21st, so it's in the process of elongating farther and farther from the sun until that date. They'll make a pretty trio with the crescent moon on December 24th, and then Mercury will loop up to the sort of outer turn of its orbit and start heading back sunward later in the month and pass just about 1.3 degrees or 1.4 degrees from Venus on December 28th. That's about a thumb's width. Now, if you're planning to look at them through binoculars or a telescope, do be careful that the sun is completely set below the horizon before you aim any optics in that direction. As I mentioned, we're getting the occultation of Mars tonight. Jupiter is going to be in the sky. I'll just give you a view of the sky here. Let's bring this back and go back to this evening so you can get a sense. What's neat is that these days, we've got all the planets above the horizon at the same time. So you can see here, we've got at about 5:15 p.m., we've got Mercury and Venus there sitting above the horizon. Then we've got Saturn. We've got Jupiter catching your eye most of the evening long. Saturn's about 20 times fainter than Jupiter. And then head on over to the northeast and you can pick up Mars and the moon tonight. The moon's going to move out of the way over the next little while. You'll also find it interesting that Uranus is tucked in between Mars and Jupiter, and Neptune, as I mentioned here on the slide a moment ago, is spotted there near the ecliptic, just a little bit, I think that's about 8 or 9 degrees to the west of Jupiter. The main belt asteroids Vesta and Juno are also hanging around in this patch of the sky as well. So there's plenty to see in terms of getting into planet viewing. If you do want to take a look at Saturn, Saturn is starting to end its visibility window for us. It's starting to sink a little bit lower in the west in the evening time. But one of the fun things about Saturn is that its moon Iapetus, which I think orbits about every 88 days or so, varies in brightness by about half, between magnitude 11, magnitude 12, when it reaches the edge of its orbit. That's because the moon itself is 50% bright, 50% dark. So Iapetus is near its minimum dimmest magnitude around now, December 2-3, and over the next little while, it'll migrate to the opposite side of the planet and brighten up. It's actually going to cross the rings of Saturn on December 22nd. Not sure how visible that might be. I haven't tried that one, but that might be something to keep an eye out for. All right, in terms of looking at things like variable stars, one of the great ones to look at this time of year is the star Algol, or Beta Persei. It's generally climbing the eastern sky in evening. It's an eclipsing binary system where you have two stars, one bright, one small, in orbit of one another. Their orbit is close to edge on towards Earth, And that means that every 2.87 days, the fainter star blocks the light from the brighter star, and it dims the light. So you've got the fainter star in front, you get a small dimming, but when the secondary star goes behind the main star, you get a deep dimming in brightness. So that takes about 5 hours to dim to its minimum and about 5 hours to recover. And most of the time it sits here at a general even brightness of about magnitude 2.2. Magnitude 2.2 is similar to the star Almach, which is nearby. I can show you that in a moment here. And when it's at its minimum, it's at magnitude 3.4, about half as bright, and it's similar to this little star Rho Persei, which is a neighbor of Algol's in the constellation. So that's kind of a fun exercise. And you can look up these events. They happen as I say, every 3 days or so. They're listed in the RASC Observer's Handbook and at other online sources. The next minimum of Algol will happen at 12:08 a.m. So after midnight on Friday evening, December 9th. And what you can do there is you can go out after dinner, find Algol in the sky at its normal brightness, and then watch it through the evening as it fades to its minimum just after midnight. And then it'll recover itself after that. Another fun variable star to check out is Mira, which is in the constellation of Cetus. It's in the neck of the sea serpent or whale. It's also known as Omicron Ceti. It's the brightest of the so-called Mira-type variable stars. So it was one of the first discovered of this type. It's a pulsating star that actually inherently pulsates, it's brighter and dimmer, and it's about 200 or 300 light years away. And this is actually a light curve of observations that people have taken over time. This is a year's worth of observations ending tonight. And you can see how it rises in brightness for about 110 days from about magnitude 9.5, and then it decreases in brightness over about 220 days. So it brightens to about magnitude 2.5 or 3, and then it fades down to 9.5. So currently it's down here near the minimum, near its minimum brightness. So that means in about 5 months, it'll brighten back up again. So it's something you might want to check out now and then remember to check back on later on. If you're interested in double stars, here are a few nice ones that you can check out. So find Orion's belt and look for a naked eye star that's just a little bit to the lower right of Alnitak. And if you put binoculars or a telescope on that, you'll see a beautiful gathering or clump of stars in a sort of a dart shape, a wedge shape. And they're beautiful. They're a neat little clump of multiple stars. Over here in Cancer, you've got Iota Cancri, which is a blue and yellow pair of stars separated by about 30 arc seconds. Those are really pretty. And then down here, once the big dog Canis Major rises, it's a little bit later in the evening right now, but it'll be with us all winter long. You can look for the star 145 Canis Majori. If you're using a go-to telescope, you might need to plug in HR2764. We nicknamed this the Winter Albireo because it's actually another blue, sort of a blue-yellow pair, really pretty. Comets. So we have one comet in the sky that's really worth looking at right now. It's Comet C 2022 E3 ZTF. ZTF, the letters in the brackets here indicate the system or robotic telescope that just made the discovery of the comet. It's currently at magnitude 10.5 and still brightening. It's in the eastern sky before dawn, rises around 3 a.m. about now. It's busy traveling north through Corona Borealis, and it is predicted to reach magnitude 5, which is easy binoculars view, maybe naked eye, I don't know. Comets seldom do what we really expect them to do. But that will happen around the end of January. By that point, it'll have reached the northern sky near Polaris, so it'll be conveniently placed for us to see it then. By the way, this picture is taken by, the Burt Gaffney Robotic Telescope. That's a free service that anybody could set up an account with and request objects to be photographed by that robotic telescope. It's really fun. Here's the light curve of that comet. These are little squares of the observations that have been reported so far. We're right around here now. And this is a great website for tracking this, cobs.si. So you can see that we're able to predict based on its passage through the solar system, its distance from us and from the sun, when it's likely to get brightest. And so we don't know if this will hold, but we're on the right track. If you want to find it in the sky, here's a star chart for it. This is the constellation of Corona Borealis, which is beside Hercules, the keystone of Hercules, and just to the lower left of the bright star Arcturus. And this is the trajectory of the comet over the next month. So from tonight till our next meeting, it'll be heading, this is actually celestial north every night. And you'll note that on the 15th of December, it'll be very easy to find. It'll be smack dab between two of the stars in the crown, Epsilon and Delta, Corona Borealis. So this is actually in the morning sky right now. But as I said, over time, it'll actually migrate nicely into the evening sky. We've got 3 meteor showers in the period I'm covering. We've got the Geminid meteor shower, which normally runs from late November to late December. It's usually the strongest show of the year. It'll peak this year overnight on Tuesday, December 13th, so that's next week. But there will be a bright moon in the sky that rises at 9:45 p.m. So you might want to get out right after dinner time, see if you can catch some meteors before the moon shows up. Once the moon does show up, you could also sometimes trick it by hiding the moon behind a building or tree to allow you to still see some of the meteors. These ones are often bright and intensely colored. They're often slower than average meteors because the source material are more rocky particles from an asteroid named 3200 Phaethon. They'll appear to be radiating from a point in Gemini. The Ursid meteor shower runs from mid-December to the late December. It'll peak on Thursday afternoon, December 22nd. So that means we need dark skies for meteor showers. That means we're limited to watching for meteors later that day on Thursday night, or maybe getting up early and seeing them on Thursday morning. We won't be quite seeing it at the peak, but we should still see some, a fewer than the peak number, but which is normally 15 or 20 at the peak. What's great is that it's going to be a moonless night that night. So maybe to make a point of seeing that one. The source material for that is Comet Tuttle, and this shower has been known to have outbursts of greater numbers of meteors in some years, so stay tuned. And finally, we've got the Quadrantids meteor shower. The Quadrantids meteor shower is going to peak on Tuesday, January 3rd on the evening, but you can certainly watch all night, and the best time for meteors is typically in the pre-dawn when the radiant is higher in the sky. When the radiant is low, half of those meteors are being hidden by the bulk of the Earth, but when a radiant is nice and high, you'll get more opportunity for them to streak across the sky. You don't want to watch a meteor showers radiant though, because those meteors are coming straight towards you and they'll have little tiny tails or streaks. You want to watch for the meteors well away from the radiant. That night we'll have a bright moon that sets at 4:30 a.m. So if you are wanting to set the alarm and get up, after 4:30, you've got a couple of hours of darkness before sunrise. This has got a short period. It's only about a 6-hour peak of intense meteor activity. We can see up to 100 per hour. Some of those would be bright fireballs, and we think the source of that is a comet seen 1490 Y1. The name of the strange name of this constellation is named for an abandoned constellation called the Mural Quadrant, which used to occupy the sky up here near, here's Arcturus, here's Bootes, Corona Borealis, Canis Venatici. So it's no longer considered a formal constellation, but that's the patch of sky it is. If you're interested in seeing satellites, unfortunately, for the next little while, most of our satellite passes of this International Space Station will be in the pre-dawn. So we have some evening passes that are going to linger until December 10th, most of those between 5:15 and 7 p.m. But then we're going to get morning passes from December 15th to January 8th, most of those between 5:30 and 7 in the morning. Here's a list of a few of the better ones I picked up, including a very, very high one almost near the zenith. That'll be just before 7 a.m. here on December 19th. Now, most of the time when we're looking at deep sky objects or the fainter objects that we're interested in, we wanted to look at them when they're highest in the sky, same as I mentioned for Mars being higher and therefore less subject to less atmospheric turbulence. So objects tend to be brighter and easier to see when they're highest in the sky. So what we do is we like to watch them or look at them when they're transiting the meridian. So when they're passing the due south direction, they're rising in the east, culminating or reaching their highest point in the sky, and then descending into the west. So I'm showing you here the constellations that are kind of passing their highest point at various times of the night on the next moonless period, which is in the December 22nd sort of range. The air mass circle. So when objects are higher, we're seeing them through less of the Earth's atmosphere. Objects that we view at the zenith we're viewing through one blanket's worth of air. As we get lower, the blanket of air gets thicker and thicker. By the time it gets to 1.5 times its usual thickness, the effects of that turbulence get stronger and stronger. So the lower you go, the more and more air is going to bother you. So things that are in the circle I've got labeled in yellow here. So here's the constellations. We've got things like Cetus. There's that Mira star we talked about. Pisces, Andromeda, Aries, Triangulum, Perseus, and Cassiopeia. I'm going to mention some deep sky objects to check out in some of these constellations. So if you're viewing them on December 22nd, they'll be near their highest points around 8 p.m. in the evening. A couple of hours later, we start bringing in Taurus and Auriga. Perseus is moving through the southern horizon, through the meridian, and we've got this lengthy constellation of Eridanus passing at about 10 p.m. Around midnight, we're getting the best time to see Orion. We're getting Gemini, Taurus, Auriga. So all these superstar constellations of winter will be culminating at their best around midnight on December 22nd. And fear not, this 12 a.m. will move earlier and earlier as we move into January and February. So no need to stay up so late in December if you don't want to. And then by 2 in the morning, of course, some people will want to be out imaging and things like that late in the evening. So by 2 in the morning, we're picking up Cancer, Lynx, and Monoceros and some of these other constellations. All right, so let me switch over to Stellarium and show you a few of my recommendations for things to look at. And I just want to pick up my notes here. Here we go. So what we're going to do is so tonight we've got a full moon. So what I'm going to do is I'm going to advance the date a couple of weeks beyond about the 16th. So the moon will be after last quarter, after third quarter, around December 16th and onwards. So if I get into the December 1920 sort of range, around after astronomical twilight, let me bring up some bookmarks here and I'll show you some great things to look at. So if you've looked at your current issue of Sky News magazine, I'm going to highlight some of the objects, walk you through some of the objects that I wrote up in the current Beyond Messier column. Everybody's used to looking at the Messier objects, but I like to indicate some other alternatives that you may never have seen before by highlighting some things in the Beyond Messier column. So number one first I've got to mention is NGC 752. NGC 752 is up here near Andromeda and Triangulum. Here's M31, the big Andromeda galaxy is nearby, as you can see. And 752 is a big, large magnitude 5.7 open star cluster. It's visible with unaided eyes on dark nights. It's great in binoculars, and you can certainly see it in any telescope, but don't magnify it too much because you want to fit it all in. It's located about 4.5 degrees from the star Almach. So Almach is that one that's actually the comparator to Algol. So there's Algol. So Algol is normally as bright as Almach, and when it dims, it's the same as Gorgonea Tertia here. So yeah, it's located about here. You can actually find it by drawing a line between Almach and, let's see, Mizan. So if you sort of go from here, you can pick it up that way. Now this cluster is very sparse. It's relatively near to the Earth, but it's also very old. We think the stars have maybe already started to disperse. That's why it's a little bit bigger. It's got a lot of F, G, and K class stars, so evolved warm-colored stars, 9th and 10th magnitude. And in the middle, you'll see a little triangle anchored by a golden star. That golden star is actually not part of the cluster. It's in the foreground, so it's between us and the cluster. And you'll want to enjoy this neat, bright pair of double stars, 56 Andromedae, that sits just on the outskirts of the cluster. NGC 225 is another open cluster. This one's easy to find because it's basically just above the shallower V, or the shallower peak of Cassiopeia. So no matter which direction Cassiopeia is oriented, you want to find the W and go above the peak of the W by about a thumb's width. And here you pick up this nice little open cluster. It's magnitude 7. It's they're actually grouped into two groups of stars. There's a little clump on one side, and there's sort of a line of stars on the other with a bit of a gap in the middle. So you might notice that. If you pull back, you might notice that there's actually, I'll just turn off the sky here for a second. There's actually a big loop of stars that kind of goes like this and like this. It's sort of a big heart shape to it. That's kind of fun. So you'll need lower power to see that. The western lobe is a little bit fainter. And if you want to do imaging on this object, now normally imagers maybe not pay much attention to star clusters, but there's actually a reflection nebulosity in here, and there's some dark dust lanes. So this would be a nice target for imaging as well. Now we move on to NGC 663. So NGC 663, I'm going to just bring up so this is actually, where's my Messier 103? So that's actually Messier 103, if you're familiar with that. This is actually NGC 663 is located here in Cassiopeia again. Now you're looking at the outer stretch of the W, the shallow half of the constellation's V, and it's basically midway between Rukba and Segin, but offset a little bit towards the double cluster and Perseus. So very bright. This open cluster is bright, magnitude 7. It's brighter than M103. It's visible with your unaided eyes, but certainly you want to use binoculars or a telescope at low magnification. Watch for a deep V of stars. So there's actually sort of two rows of stars in a V shape. And you'll notice that if you look at the tops of the V's, that each of these pairs is a double star under more magnification. And then above it, there are actually a couple of red giant stars. So there's a couple of red stars here. And when you combine these two, if you make these eyes and this sort of the downturned mouth, it almost looks like the aliens from the Muppets. All right, a couple more. Now we're done. 925. So NGC 925 is a galaxy. This one's sitting here in Triangulum. The easiest way to find this one is to locate or identify the 3 stars of Triangulum. Then you want to hop down this span from Mizan to Gamma and hop by that same distance, but in the direction of, from Gamma, in the direction of, the rest of Perseus down this way. This is a not quite open, not quite face on. It's a little bit of an oblique spiral galaxy. It's the second brightest deep sky object in Triangulum after M33. It's visible in, say, 80 to 100 millimeter telescopes and larger telescopes on moonless nights. And you can use averted vision and see if you can see sort of the S shape of these dominating arms. Now, let me show you a twofer, 672. So 672 is kind of a 2 in the view. It's a bit reminiscent of a mini-me version or a miniature version of, M81, M82, or the whale and hockey stick that we see in the springtime galaxy. This pair is medium dim, so you need a bigger telescope to see these. And the way to see this set of objects is to find Hamal, the bright star in Aries. And if you go from there up to Merak in Andromeda, it's basically on that line, and it's just the tip of Triangulum kind of points to it. So if you put your finder scope with the low power, wider field eyepiece, you can pick up these two. They are, let's see, visible in a telescope, bigger than 80 millimeter if you have it, and definitely if you can find, try it on a moonless sky, you'll be better off. And last one is, I think one of the coolest ones, is the Fiddlehead Galaxy. This is surprising that this wasn't on Messier's list. It's a bright galaxy. It's fairly easy to pick up in a smaller telescope. It's a peculiar galaxy, so it's called ARP 78 from Halden Arp's Index of Peculiar Galaxies. It's here in Aries, and one of the greatest ways of finding it is to find the main brightest stars of Aries, so Hamal, Sheridan, slightly fainter Mesarthim, And then make a right angle down towards Taurus by that same span. Very easy to locate. You want to look for, if you can, use averted vision. Maybe you can pick up the dominant arm that swoops to the north and to the west. And if you've got it, if you're imaging it, or if you've got a bigger telescope, you can look for the little elliptical partner that we think might be the cause of the distortion, the gravitational interaction between those two galaxies. So that's it. Hopefully you can get out and get some clear skies and enjoy that. And I'll leave you with that.
Great. Thank you very much, Chris, for a very comprehensive look at the sky this month. Thank you so much. Let's go to Emma. Do we have any questions?
Yeah, we got a couple of questions in. First up, Leo says, can we see this through the clouds? Where's my cloud filter?
Hey, I'm going to get my telescope out. It's moon, the full moon in Mars will cut through thin cloud. I think it's worth a try if you've got thin cloud.
Very true. We also got a second comment from Eric Briggs, who says there's an interesting asteroid occultation coming up Friday morning.
Nice. Well, share that on the forum, Eric, so we can all benefit.
That's it for questions and comments.
Great.
Thanks again, Chris.